All right, ladies and gentlemen, we're doing 7-1 right now, exploring exponential models. You need to get a book, get your note page started up there. Okay, page 305, you need to figure out what the standard form of an exponential function is, what each part means. Okay, define it up. Get about a minute there. Okay, standard form of an exponential function, y equals abx. What does a stand for? Yeah.
It's the constant.
It's the constant, also in our graph. Yeah. Does not equal 0. Okay, a is called our initial value. Okay, a cannot be 0. All right. A on a graph, one thing that you're going to want to write there, a on a graph is your y-intercept. It generally is your y-intercept until we start shifting it. Okay, so a is our y-intercept when h and k are 0. Okay. Now, we haven't put in HK up there, so right now they are 0. We can't see them, so they are 0. Okay? B is the base. It's either a growth factor or decay factor. Okay? Once again, when B is not 0, B is also when it's not negative. Okay? B has to be greater than 0 there. If B was 0, what would happen here? Everything's 0. If b is 0, 0 to anything is 0, times a is still 0, so you get y equals 0. You get a flat line. It's linear then. In fact, if a is 0, you get whatever you want over here for b, but then you're multiplying by 0, so once again you get a flat line, a linear equation. Okay. Any questions there? Yeah?
Isn't this just like the quadratic stuff, except for it's just like half of it?
It may kind of look like that. It's not that, but like picture-wise, it may kind of look like that.
Oh,
okay. So you kind of following along with that. Okay, there are two different pictures on page 305 that I put up here. Okay, the growth factor b affects the value y of an exponential function in a certain way. I want you to take a look at these. Okay, and explain how you know a picture is growth, how you know a picture is decay, and then describe how you know it pictorially, which hopefully is pretty easy. Okay? But put it in words and describe how you know it equation-wise. So in equation form, how do you know it's growth? How do you know it's decay? And pictorially, how do you know it's growth? How do you know it's decay? All right, someone describe for me, how do I know pictorially something's growth? Yeah.
If it's going upwards to the right.
If it's going upwards to the right, everyone agree?
Yep.
What's another way of saying that? Park?
Increasing past the y-axis.
Okay. What's another way of saying it? Yeah?
That graph is positive.
Graph is positive. So thinking slope-wise. Okay? All right. As x increases, y increases. You guys, that's a general statement for a growth or a positive slope. Okay? As x is increasing, y is increasing. Exponential decay in picture, as x increases, y decreases. Okay? Or the graph's falling from left to right. If you read it like a book, from left to right, the graph is rising. From left to right, the graph is falling. Okay? So in terms of your equation, b has to be greater than 1. Here, b has to be less than 1. Okay? We want it greater than 0, though. All right. Any questions there? Yeah. Tyler?
I was looking at my calculator and I put x in it negative, and it was exponential decay. So is that
When you put x as negative?
Yeah.
Yeah, that's a good point. So you're kind of jumping the gun a bit. When you put x as negative, remember what happens. We just went through those properties. When you make a negative here, so if I had a b to the negative x, what happens to b? It becomes a fraction, right? It becomes 1 over b to the x. So if I had, say, like 2 there, that would be y equals a times 2 to the negative whatever, we'll put negative x, that ends up becoming 1, or a to the 1 over 2 to the x. So it becomes a fraction. What was growth, when you make that negative, that x term's negative, becomes decay. So it becomes a reflection. It's actually reflecting over the y-axis. Okay? You change that, it reflects it over the y. Okay, so there's a lot of things, and we'll kind of explore that a bit more in 7.2. So you're jumping a little ahead, and that's good, but we'll explore it a little more in 7.2. Okay? For now, we just want to know our growth factors and picture-wise. Questions there? All right, next piece. So you need a graphing calculator for this piece. I want you to graph these questions, or excuse me, these graphs here on the same coordinate plane. Only a couple people graph. Can I borrow your calculator? Thank you. They all say X. Yep. Okay, so Lee's put them in there. She's been kind enough to loan me her calculator, so there we go. Okay, got them in. We graph. Okay, and I'm going to go back here. I'm going to turn this one, or these two off there. That one and that one. I hit graph. There is my 0.5 to the x. We note that that is what type? That is decay. Where does it appear to hit the y-axis? 2. We could check that using what feature? Could calculate. We could also look at the table. The table, if it hits at 2, what should x be there? 0. So I'm going to have to change the table set here. We're going to make this 1, or -1 there, and going up. Okay. All right. So good. 0, 2. All right. We plug in the next one. Okay, we hit graph, we get a straight line. Tell your neighbor why that's a straight line.
Because 1 to the anything is just 1, so 1 times 2 is always going to be 2.
Hey, volunteer. Parker.
Because it's 1 to any power is going to be 1. So, well, any real number power. And 1 times 2 is 2, so y equals 2, and it's a flat line.
Good. So it doesn't matter what we put here for a power, it's always going to be 1. And so 1 times 2 is always going to be 2. It's going to be a flat line. Okay, the next one, we know since it's greater than 1, should be growth. We verify it. But they all cross at the exact same place, and that is 2. Why do they all cross at 2?
Because 2 is A.
All right. Someone from the back row, why do they cross at 2? Back row. All right, we'll count you. Because A is 2. And A is our y-intercept when H and K are 0. Okay, we've talked about what would happen if A is 0. Talked about it, but we get
It would become a flat line.
flat line. We get the equation y equals 0. It would be a flat line. Okay? What would happen if B was 0? Yeah, Cole? Flat line. Once again, you get a flat line. Okay? What would happen if B was negative? It's a bit different to think about. Go ahead.
Wouldn't it be a decay because if B is less than 1, then it's a decay?
Let's take a very basic one. Let's say A is 1. And we'll call this 2 to the negative, or excuse me, we're making this negative. We'll call it like that. Which, by the way, we usually see like this. We wouldn't show the 1 there. So if you don't see a number out in front, another thing to put is A is 1. You're going to see that a lot. All right? The thing to keep in mind here, if I was making a table of values and I had -2 to the power of x, and I say I had 0 there, which is how I usually start these out, and that's -2 times 0, or to the power of 0. Anything to 0 is 1, so this is 1. But when I put 1 in here, and I go -2 to the power of 1, what's my answer? -2. And then when I put 2 in, and I go -2 to the power of 2, what is that?
4.
That's 4. And now when I go to 3, what is that?
Negative.
-8. And when I go to 4, believe me, I'll stop doing this here in a minute. But what's that? Oops, that's yeah. This would be not -3, that's +3, and this would be +4. Excuse me, but that's 16. What's happening with my graph?
It's going positive and negative.
Yeah, it's doing some crazy, I mean, it's like you got 0, 1, then all of a sudden you're at 1, -2. Okay, call that 1. And then you're at 3, or excuse me, at 2, and then 4, and then at 3 and -8, so you're down here, and then at 4, so your graph's going, I mean, it's going, I mean, it looks like someone's heartbeat. Okay? Well, hopefully not, but you know what I mean. It's a zigzag kind of weird graph, right?
It's not even graph on here.
So, yeah, the problem is when b is negative, you don't have an exponential function, even though it looks like one. Okay? But it's not an exponential function. All right. Make a note there. What happens if x was 0? We talked about it. Anything to the 0's power is 1. So everything would be raised to 1. That would mean I'd have 2 times 1.5. I once again would get a flat line. I get a linear equation. Okay. All right. What can we conclude about the b base and its effects on the graph? We already talked about it. Sorry, I gave away the end of the story before we got there. All right. So what is growth and decay? Just to make sure we've got this summarized. Exponential growth. B is greater than 1. The y values increase as x values increase. Words like appreciation describe growth. What is exponential decay? B is less than 1. The y value decreases, x value increases. Words like depreciation describe decay. Now, you guys, let me remind you as a class that this chapter, this is one of the 3 chapters we cover this semester. 7, 8, 9. That's it. The beginning of this chapter was the intro, which many of you had forgotten. This stuff seems extremely easy. At the end of this chapter, when we get done with logs, and I go, hey, remember 7-1? You're going to be like, maybe. It seemed easy then. You better have good notes. Okay? I'm not trying to scare you. I'm just letting you know ahead of time. Out of the 2 chapters in the book, actually 3, last year students voted this one the hardest. The year before they said 8. Actually, they said 7 was hardest too. The year before that was 8. A couple of times I've had 9 being the hardest. So please, take good notes. I'm telling you now, take good notes. Don't be the one that goes, man, I wish I would have said, or I wish I would have listened. But you won't ever tell me that. You'll just like, oh. All right. Any questions there? All right, moving on. Why will our graph never cross the x-axis? Let's make sure we're clear on this. Okay, so Tyler, this kind of goes back to what you were talking about. 3 to the 4th, what is that? You don't have to copy all this. Just pay attention on this. 3 to the 4th is what? 81. 3 to the 3rd? 27. Start memorizing these. It'll make your life a lot easier this chapter. 3 squared?
9.
3 to the 1st?
3.
What are you doing every time?
Divided by 3.
Dividing by 3 or multiplying by a third. Why are we dividing by 3 or multiplying by a third? Because it's a power of 3, man. If it was a power of 2, if the base was 2, we'd be dividing by
2.
If the base was 7, we'd be dividing by
7.
What is 3 divided by 3? That's why anything to the 0 is 1. Because you would always have, if it's base 7, you'd be dividing by 7, you had 7 divided by 7 would be 1. Okay? You always, anything to the 0 is 1. Well, what is 1 divided by 3?
1/3.
That is 1/3. What is 1/3 divided by 3? It's 1/9, or 1 over 3 squared. What is that divided by 3?
1/7.
1/27th, or 1 over 3 cubed. What is that divided by 3? 1 over 81, or 1 over 3 to the 4th. Okay? You are getting infinitely close to what number? 0. You are never getting there. Now, I am trying to deal with a Seahawk loss 1 yard from the goal line. Now, I know the drive did not start at the 0 on the other end, but if I went 0 halfway to the goal, I'd be where? The 50. And then from the 50, I go halfway to the goal, I'd be at the 25, and then to the 12.5, and then to the 6.25, and then so on. Well, we wouldn't actually hit the 1 there, but we got to the 1. Okay, I keep thinking, man, they could have done anything in that last play. They could have had pass interference. If you know anything about football, pass interference, if it's a 1 yard, you get half the distance to the goal. We would have went to the half yard. They could have done pass interference the next play. It would have been half the distance to the goal. They could have done pass interference the next play. It would have been half the distance to the goal. I'm really struggling with this. Okay? Now, would they ever have gotten in the goal with a pass interference call?
No.
Never. They would have just kept going infinitely closer to the goal. They would have never got to the goal. It depresses me. Now, we're going to be studying logs later this week. I know what LOB means. We're going to be doing LOG, which is where I'm at right now. It doesn't actually mean Legion of Gloom. It means logarithm. Okay. I am in the Legion of Gloom right now. All right. Hopefully I will come out of it. Seahawks Mariners better have a good season. All right. I know, when I'm relying on the Mariners, we got problems. All right. Here we go. Graphing exponential functions. Turn your graph page over, please. Or your note page over. Okay. Graphing exponential functions. First thing you need to do is find the y-intercept. Tell your neighbor what the y-intercept is. A is our y-intercept when h and k is 0. It's always A when h and k are 0. Find 2 points on both sides of the y-intercept. So once we find the y-intercept, we'll pick 2 points. We'll figure out if it's a growth or decay. We'll do a quick sketch of what we think the picture will look like. And remember, the graph will never cross the x-axis. It'll get infinitely close. Now, there's a little side note to this. It'll never cross the x-axis when k is 0. Because if k is negative, it's taking that graph that never crossed 0 and it's shifting it which way? Down. K is an up-down shift. Right? We've studied HK this year. K is an up-down shift. So if k is negative, our graph shifts downward from 0. Okay, so if k is like -2, the graph that doesn't cross 0 now doesn't cross what? Now I'm asking you to think of a lot in your head without seeing a picture, which we will study tomorrow. Okay, but if I have a graph that doesn't cross 0, say that one, and then I say, well, maybe that's y equals 1/2 to the power of x. And now I say, well, let's change that up and put -2. This graph just shifts down. How many units? 2. So rather than not crossing 0, it now doesn't cross -2. Okay? So the side note here, once again, is when k is 0. All right? Then we'll test some big values like 10 and -10, the small values, and figure out where the graph is going. So what I want to do is I want to graph number 1. Number 1, 6 times 1.13 to the power of x. Okay? All right. Right now you have a place to put it on your paper there. Your grid, we're going to try to graph that. Go ahead and figure out some values there. Follow those steps. Find your y-intercept, figure some values. You need a grand total of 2, 4, right? 2 on each side. 2, 4, 5, 6, 7 points on this. At least for this problem. Okay? Go for it. All right. How many of you started right here with your y-intercept? Okay, this is your y-intercept. I put it right in the middle. Its y-intercept is when x is 0. Okay? In this case, when x is 0, it gives my y-intercept. This part becomes 1. 6 times 1 is 6. It's your a value. Okay? Y-intercept. I'm going to write it here, actually. Okay? Now, picking 2 points on either side of the y-intercept, that would mean like if I maybe chose 1 and... Anyone use 2? 2? Okay. Anyone use 3? Anyone use 4? Okay. So I'm going to use 1 and 3 just because then I have to. Anyone use... I could have used 2. Anyone use -1? Anyone use -4? -3? Okay. All right. Give me a value for 1. 7 point what? Okay, 6.78. Okay, so 6.8. Anyone get a value for 3? 8.7. Okay. How about -1?
5.309.
Okay, 5.3 and -3? 4.2. Okay, this graph should approach what number on the y-axis? 0. Okay, if I'm graphing it, I got 0, 6. All right, I've got, no, let's just start here. 3, 8.7. 1, 2, 3, 1, 2, 3, 4. And right about there, a 1 and 6.8. I got -1 and 5.3. And -3 and 4.2. Now the problem with what the things that we chose right now, it's not showing much of a curve at all. It almost looks linear. I mean, really close. If we chose 10, what's 10?
20.367.
Okay, so really what that does for us is it shows that it keeps going way up really fast. It's like way up here. Okay? 10's like way up in yonder. Okay, what's -10?
That is 1.7675.
1.8.
That'd be 1.8.
All right, so -10's 1.8, so it's like way over here. All right, so it's very tough to see that curve. Did anyone pick? Someone please just quickly do like what
Brother.
6 is,
6 is...
or -6? Excuse me.
2.88.
Okay, 2.8. What I want to make sure you guys do when you're graphing these is to see the curve. Okay, and by putting those values in, you can start seeing that curve a little more. That is our graph. It is decay. Or, excuse me, growth. Thank you for correcting that. All right. Questions there? That's how we complete a graph. There is my table, by the way. Okay. I used some different values, but there we go. All right. Your assignment today is to finish this page, if you haven't done so. Okay? Tomorrow we will finish up our notes on 7.2 or 7.1. All right?